All right, this is going to be the Chapter 13 Learning Target number 1 video. And you can see the first target here is I can collect, organize, and tabulate data. Now that word right there might seem a little bit weird, might be kind of new, but I promise you that this is the easiest target in the whole chapter. You guys are going to think so as well. So let's go ahead and flip down to page 2. Alright, so basically this target's all about just data collection. And for instance, you can see Sean wants to find out how students in his class get to school. Okay, so he's going to do maybe a survey. Well, I guess here he's got his methods right here. One method is he's just going to observe. He's going to stand outside and watch how many people come from walking, how many people come from the bus, how many people ride their bike, how many people get dropped off by their parents in their car. And he's just going to keep track of who does what. So that's one method of collecting this data. So right there, method 1. Method 2, conducting a survey. Okay, so Sean can interview his classmates to find out how they get to school. So he asks his classmates, how do you get to school? They say walk, my parents, bike, bus, whatever. Okay, method 3, so this is method 3 right here, conducting surveys using a questionnaire. So maybe that's a Google Doc or something like that. That he's created, and then people can quickly do from their devices and just answer a quick survey of how they get to school. So basically what he's done here is he's created this little chart here. And like I said, it's called a tally chart, really. We can call it a tally chart. Yeah, these are so basic. I mean, we've all done these, I think, at times. If you don't know how to tally, we'll go over that real quick. I'm assuming everybody does, but if you don't, here's what it is. Okay, so when you count tallies, what you do is you go 1, 2, 3, 4, and on the 5th one you slash through it like that. So then that's a good way to count, because if you're trying to like keep track of something, like how many people do something or whatever the example is, he's just going to keep track. So for instance, if he were conducting surveys through interviews, he would go through and say, okay, or this method, either method, but he'd go through and he would say, okay, I had 12 people that did the bus. Okay, so that would be 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12. And that represents 12. Okay? This is a much better way than just counting them and then putting 12, because what if somebody else adds to it then? Then you got to cross it off and put 13. Whenever you're counting something, this is a great way to count using tallies. Okay? So that's basically what he did here. However he used, whatever method he used doesn't really matter to us, really. We just know that now he created this tally chart. And we can see that he did 1, 2, 3, 4, 5, 6, 7, 8. So evidently 8 walked. We have 5, 10, 13 rode the bus, 4 rode their bikes, and then 5 were driven by their parents in their car. Okay. Now the frequency refers to how often a piece of data, such as an item or a number, occurs. So the item here would be walk. So this number here is just representing the tally in number form. So as I said, if this seems really, really easy, it's because it is. Okay, so let's go on down to the next one. Now we can look here real quick. Here's some generalizations, I guess would be the word, or some things you can take from this chart right here. 8 of Sean's classmates walk to school. Okay, yep. The most common form of transportation is the bus. I think that would be probably the same here. The least common form would be the bicycle, probably the same as it would be here at Chanahan. There is one more classmate who comes to school by car than by bicycle. So there's one more here than here. And then Sean collected data from 30 classmates altogether. Okay, so if you added all the tallies together or you added all the frequency together, you would get 30 there. Okay, so like I said, if it seems easy, it's because it kind of is. It's really, really basic. So we'll go down here. You can see that this is one we're going to complete together here. It's might be kind of hard for you guys to see, but you have your copy, so that's all you need. Emma used a questionnaire, so maybe a Google Doc, something like that, to find out the number of brothers or sisters her classmates have in their family. So if you were a student in the class, you could have 0 brothers or sisters, 1 brother or sister, 2 brother or sister, 3 brother or sister, 4, and so on. You could have any number. Now what Emma did is she asked how many people have 0, 1, 2, 3, 4, or 5 or more. So she cut off at 5 or more. She could have kept going 5, 6, 7, 8, 9, 10, but obviously the majority of people have between 0 and 5 brothers or sisters usually. It's not like, I mean, there are extreme cases where there is like 8 or 9, 10 people in a family, but in this case, this would be the general or the majority of people. Copy and complete the table. So you can see that when she did this little questionnaire, she saw that the number of brothers and sisters, she started with 0, and she obviously had 3 people that they're only children, which means they don't have any brothers or sisters. So for frequency, we're going to put 3 right there. Okay, then for 1 brother or sister, 5, 6, 7, 8, 9. Okay, for 2 brothers or sisters, 5, 6, 7. Okay, and then for 3 brothers or sisters, there's just 5 there. Okay, notice how I'm counting these tallies by 5s. Okay, I'm not going through and going 1, 2, 3, 4. When you see this, and you see that slash, that is the same number as number 5. It's the same exact thing. For 4 brothers or sisters, there were 2, and then anybody that had 5 or more brothers or sisters, there was only 1 of those individuals. Okay, so there we completed the table there. That's all good. More of Emma's, this is just for that right there, by the way. More of Emma's classmates have blank brother or sister than any other number. Okay, well, you go here, which frequency was the highest? Clearly that is going to be more of Emma's, I shouldn't say more people, more of Emma's classmates had 1 brother or sister than any other amount of brothers or sisters. Blank of Emma's classmates have 3 brothers or sisters. So 3 brothers or sisters, that would be 5. 5 of them, 5 of her classmates. Blank of Emma's classmates have 4 brothers or sisters. That would just be 2 of them. Okay. How many more of Emma's classmates have 2 brothers or sisters than 5 or more brothers or sisters in their families? Okay. So we have, for 2, we had 7 people that had 2 brothers or sisters, and we had only 1 person that had 5 or more. So obviously that would be, there would be 6 more that have 2 brothers and sisters. And then Emma has blank classmates altogether. So in that case, now we would add all these up. Okay, so 3, 12, 19, 24, 26, 27. Okay, 27. And maybe you could make the argument that the answer should be 28. I'm not sure. It doesn't really specify here whether or not Emma included herself in this. So if you're talking about her, well, I guess since it says Emma has 27 classmates, then you wouldn't want to put that because it's including Emma. Regardless, once again, seems very, very easy, I'm sure, to all of you right now. Okay, we can look at this one real quick here. We won't go too much farther, but a shampoo company wanted to find out more about its customers, so they asked 30 customers to indicate their income bracket. So, did the customers make $500, below $500 per week, between $500 and $1,000 per week, or over $1,000? So this is what the company found out, that 5, 6, 7 people made below $500, 5, 10, 15, 19 people made between $500 and $1,000 per week, and then only 4 people made over $1,000 per week. Okay, so then again, we have this all organized. Now we can just easily answer questions based on the graph. Every graph we do in this entire chapter, the whole point of graphs or displays or anything like that is to give us a visual. Okay, so this just gives us an idea. We can look directly from that and we can gain knowledge from it. How many customers have a weekly income of $1,000 or less? Okay, so you can see of $1,000 or less, that would include those 19 and those 7, right? So in that case, we answered a question regarding 2 of the groups. So that would be 26. Okay? It wouldn't just be 19 because it wants to know anybody. That means somebody that made $300 a week or $900 or whatever. Okay? That would include both of those groups there. Okay? This will be the last one we do here. Okay, now this would be kind of what it looks like. Now, if I gave you that big, long data, all those numbers right there, I guarantee that doesn't mean a thing to anybody. Okay, and that's what displays and these tables and different things like this do. They give us a visual so that we can make very simple observations from it. so we can answer questions. I can't answer anything about this. So a math teacher wanted to find out how many hours per week his students spent on math homework. Okay, so obviously he did maybe the teacher did a Google Doc or a SurveyMonkey or something like that, or maybe like me, I would use my clickers and I would just say how many hours do you guys spend per week on your homework, and obviously somebody keyed in 5, 3, 6, 8, 2, 4, 2, and so on. Okay, again, this doesn't really, we can't answer a lot of questions from that. That's called raw data or data. Okay, that's just raw data right there. That is just bunch of numbers listed in a row. Doesn't really help you much. You got to put it into a graph, put it into a table so that you can do something with it. So now if I'm that math teacher, I can't do anything with all those numbers. So what I'm going to do is I'm going to make maybe a tally chart. Okay, so I'm going to look at this and I'm going to see, okay, how many people had let me do this real quick here, make this a little thicker so I can just highlight. How many people were between 0 and 3 hours? So there's 1, there's 2, and you should be circling these or something like that. If you have a highlighter, that's fine, but if you don't, circling is fine. So as you can see, I'm going through and I'm picking out everybody that just spends between 0 and 3 hours. Make sure I didn't miss any there. I think I did. So then we're going to count them. 1, 2, 3, 4, 5, 6, 7, 8. 1, 2, 3, 4, 5, 6, 7, 8. So that would be 1, 2, 3, 4, 5. 1, 2, 3. That's 8. 6, 7, 8. And of course our frequency then would be 8 as well. Okay? We use a different color here. Now we want to figure out everybody that was from 4 to 7. Okay, that would include that person. 4 to 7. 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 Hopefully I'm not making any mistakes. Looks good right there, okay? So once again, here we go. Now we're going to do our tallies here. So we'll count the ones in yellow. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13. So it would be 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, and then 1, 2, 3. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13. And then our frequency would be 13. And then 8, and then you don't have to color these ones in because we know whatever's not highlighted, but I'll do that anyway. So anybody from 8 to 10 then. So we got 1, 2, 3, 4, 5, 6, 7. Okay, so 1, 2, 3, 4, 5, 6, 7, and then our frequency then would be 7. Hopefully I didn't make any mistakes there. Okay, so once again, now I can do something with it. So I'd say about half the class, more than half, is or less than half actually, is between 4 and 7 hours. So again, then I can answer questions. I can figure out what I got to do. Am I giving too much homework? Are you spending too much time? What's going on? So this little display does a lot more than this raw data up here. How many students spent more than 3 hours per week? Now notice that says more than 3 hours. Okay, now this goes back to chapter, I want to say, would it be, I think it's 8, chapter 8, where we did at least, at most, remember all those, more than, less than, you had to write inequalities. If we want to spend more than 3 hours, if we were talking about the actual inequality, it would look like this. X would have to be greater than 3. Remember, X is just the number of hours. That's what I'm looking for. So how many people spent more than 3 hours? So would that include 3 hours? No, it would not. We would not include anybody that has 3 hours. It would have to be everybody that's 4 or more. Okay? So we know now that we would look and say, well, that would be more than 3 hours. That would be more than 3 hours. So that means 20 people spent more than 3 hours on their math homework. Now, as a math teacher, I can maybe ask myself, is that too much? Should I change something up? Different questions like that. Okay? There's a few more there. We're not going to go on to those. I'll just talk about it real fast. I mean, like this one, this isn't a number list, but again, that's just a big list of things. So obviously people went through and did their favorite fruits. You just have to go through apple. Okay, well, how many apples? 1, 2, 3, 4, 5. Looks like 5, so 1, 2, 3, 4, 5, and then 5. And then you would fill that out, and then of course you can answer questions from that table. Up here it'd be difficult. It would take a lot longer. So that's why we organize things into graphs. All right?